We are replacing the HDMI connector on a PlayStation 5. There is only one pin bent down inside the connector, but the outside of the connector is bent badly. The first thing we're going to do is remove the EMI pad. This pad helps reduce interference for the video signal around the HDMI port. And the pad's a little bit stuck in the one side, but it does eventually come out with a little bit of effort. There we go, and you can see how badly bent the HDMI connector is. Usually when they're bent this bad, it's a sign that somebody possibly tripped over the cable. We're going to go ahead and add some low melt solder to the legs of the connector. We've got the new Hdmi software up on the screen. This software monitors the soldering iron temperature. When we pick the iron up, you can see it automatically exits sleep mode and starts heating up to the set temperature. And then we're going to grab our iron and some low melt solder. And you can see the software on the screen shows the temperature of the soldering iron in real time. You can see with this large of a tip, we don't even lose much heat applying low melt to the legs on the connector. And we're just going to mix that low melt solder in there. This low melt solder is from Chip Quick. And we're just going to make sure we have plenty on there for some thermal mass. This is the Hdmi 971. Grab that little tiny piece off. And flip the board over. We're going to go ahead and apply some low melt solder to the connectors on the HDMI port as well. I do have a couple different tips on the way for this iron, so we'll be trying those out when they arrive. And not having the best time with the solder and this tip here, just testing out this brand new tip. It's a little bit large for this, so struggling here a little bit to get this applied properly. I do end up grabbing out a different iron with a different tip just to get this applied properly. This is a bit of a struggle here with this large of a tip. And I planned to replace that cap. That's why we didn't worry if it got knocked off. And we're going to apply some flux to the top side of the legs on the connector as well, just to make sure that we've got low melt all the way through the board. The PlayStation 5 board is a little bit thicker than some boards, so we want to make sure that we get low melt all the way through. And you can see the temperature of the soldering iron is pretty stable, even when heating up a large area like a connector that pulls a lot of heat. The connector acts as a heat sink and pulls a lot of heat, but the iron is still able to stay warm. Some soldering irons do not compensate for heat loss. That can make them much more difficult to use. And we're going to go ahead and use our smaller tip here and apply some low melt to the pins on the connector. You can see how long the low melt solder stays liquid. This particular low melt is supposed to melt at 136 degrees Fahrenheit. Almost finished up here. We're going to grab the hot air station and start applying heat to the connector. We do apply some heat to the bottom of the connector, the top of the connector, and kind of all the way around to make sure everything is warm and heated up in liquid. You don't want to pull up too hard on the connector. You can end up ripping the pads off of the board. And it's off. We're going to go back under the microscope and clean this area up. We're going to start by applying flux, and then we're going to grab some solder braid, the soldering iron, and go over the entire area wherever there's solder to wick it up. And you can see how quick that solder just wicks right up into that braid with the flux on the board. Just like that. Squeaky clean. And the holes where the legs go are a little bit harder to get cleaned out. The PlayStation 5 board is thick enough that it makes it difficult to wick the solder out sometimes. The small size of the holes does not help either. I'm going to flip the board over and wick the solder from this side as well. You can tell the solder doesn't wick on this side near as nicely without there being flux on the board. I'm going to add some flux and try again here. We're going to flux it up on both sides. And then we're going to see what we can get wicked up. Flux is definitely your friend with this process. It helps out a ton. Still not quite the results I was looking for, unfortunately. And you can see how much better the solder wicks up with the flux on the board. That hole did wick all the way through. We got all the solder out of that hole there. Not quite as lucky with the other three. This here is what the board looks like. We've still got to get the holes cleaned out in the connector, but we're going to end this one here.